Hello everyone. Today's lesson is going to be on the continuation of solving equations. So you already know how to solve a basic equation, and these are the general steps to solve that equation. But today we're going to focus on solving equations that have special cases. So we're going to get into what that means. So what is a special case of an equation? So when it comes to solving an equation, we're used to just saying like, oh, solve the equation and then x equals something like 7. We have our one solution and we're done. But not all solutions not all equations will just have one solution. And this is where our special cases come in. So when does a special case happen? Because we haven't really seen any of these in this class at least. You may have seen them in other classes. So what happens for us to get this special case of an equation? So this happens when the variables cancel out. So when they are eliminated. So when the variable x or any other variable disappears, that is when we have our special case, because we cannot solve for x. So if x goes away, if it's eliminated, then we have the case where there is no one solution, x equals 9 or whatever. So we discovered that this may happen when doing the following steps. So it usually happens in the following steps when we combine like terms. So we combine x's on one side of the equal sign. We can have our variables eliminate. Like if we have 5x minus 5x, that can make the x's disappear. So like in step 2, and it can also happen in step 3 when we move the variable x from one side to the other side to combine it with one on the opposite side. So this is when our variable will get eliminated or will get canceled out, and we're going to end up with just numbers. So all the letters are gone. So when the variables are eliminated, our solutions will be one of the two following. We can get no solution, or we can get infinitely many solutions. So again, many solutions, or no solution whatsoever. So these are our two cases where we get one solution, or do a no solution, or many solutions. So no and many. So these are our two cases, along with the one solution that we've already seen from before. So this is just when we get x equals a number. Now, so how do we know when the variable cancels out that we have no solution or many solutions? So let's look at what we have here. So we get no solution if we get a false statement, meaning something like 7 equals 10. That the side of the left of the equal sign is not equal to the right side. So this is when we get a false statement. Versus on the many solutions or the infinitely many solutions, if we get a true statement. So once our variable cancels out, we get something like 3 equals 3. This is a true statement. So these are our three cases of solving equations. You always get one solution. If the variables eliminate, no solution. Or you can get many solutions if the variables eliminate as well, but you get a true statement. So let's go ahead and see what this looks like. All right, so we have this equation. This is a multi-step equation. This can also happen with simple ones, but remember, we have to at least either have one of two things happening: variables on both sides, which we have here, or combining of like terms, which we also have here on the right side of the equal sign. So when we go ahead and solve equations, we always want to start off with doing any distributive property, if possible. In this case, we can distribute, so let's go ahead and do that first. So we're going to distribute the 8 times 3 and 8 times 10. Just do those basic steps, 24x plus 80. And on the right side, we just bring it down. Second step would be combining like terms, so I'm going to go ahead and do that. The 28 and the 4 are on the same side, so therefore they can combine. So 28 minus 4 is 24x. All right, now we're going to go ahead and do step 3, which is move the variable to the same side. So we have variables on the left, we have variables on the right. Notice that they're both 24x. So this is going to cause them to eliminate, because when I subtract the 24 from the right side to the left side, they're both going to eliminate. So they're gone. So both variables are going to disappear, both from the left side and from the right side. So we are no longer having any variables. So we're only left with 80 on the left side and negative 14 on the right side. So now this is a special case where we decide, is there no solution or infinitely many solutions? In this case, my statement is false. So because my statement is false, that means I have no solution. So we just write down the words no solution. So this equation has no solution, no matter, there is no x term that you can plug into these x's here, where the left side will equal to the right side. Let's go ahead and do number 2. Just like any equation we've done before, look for distributive property and combining like terms. So this time I'll do both at the same time. So on the left side, I'm going to combine like terms. So 6w and 3w, both have a w on them. On the same side of the equal, so 6 minus 3, we get 3w. Bring down the 5. Bring down the 14. On the right side, we can do a distributive property, so we're going to go ahead and do that. When we multiply, not only do we multiply by 3, we multiply by a negative 3. So we get negative 9 and positive 3w. Now we're going to go ahead and combine like terms. On the right side, the 14 and the 9 can still combine. So 14 and 9 are on the same side. They can combine, so that's going to give me 5. All right, now I'm going to go ahead and do step 3, which is move my variable to the same side. Again, I can already see that it's the same variable, 3w. So when I move it, it's going to cancel itself out on both ends. So they're both gone. So I'm left with 5 equals 5. This right here is a true statement, which means we have infinitely many solutions. All right, so that's the general idea. Again, variables will not always cancel out. We know that. We've done many equations, but sometimes they do. And this is when we have to make sure we know the difference between true, false, meaning no solution, infinitely many solutions. Let's go ahead and move on to the next one. All right, number 3, we have something slightly different here. We have a fraction, and there's no need to worry. This is still a 2-step equation. We have to get rid of 2 numbers from our x that are on the same side of x. There's my equals. That we want to move the 9 and the 4. Remember, we always want to move the integer variable. This is going back to the last 2 steps. So moving the number to the other side of the x. So I'm going to go ahead and subtract 9 on both sides. So I'm going to do minus 9, not minus 9. But these cancel. We bring down the x over 4. It's okay that it's a fraction. It's not a big deal. We get 7. All right, now we have to decide, how do I get rid of that 4? Because it's x divided by 4. The opposite of dividing by 4 is multiplying by 4. I do it to the left side, I do it to the right side. Again, remember the whole purpose of multiplying by 4 is in order for them to eliminate, because 4 divided by 4 gives me a 1, so I can just cross these out. So I'm left with x equals 28. So in this one, I have one solution. The x didn't cancel out. There was no combining like terms to make the x go away, and there was no moving x from one side to the other one to eliminate. So again, just want to reiterate that not all equations have this special case. So sometimes you will have that one solution. And you don't have to write one solution. It's there, the one. All right, last one. We're going to go ahead and combine like terms on the left side. The 5 and the 9 can combine. So we're going to get 9 plus 5, which is going to give me 14, minus 4m equals, on the right side, I can do the distributive property. 15 plus 5m, bring down the 9m. Now we're going to go ahead, on the right side, we have a lot of terms. That means we can probably do a combination. So we can combine the 5m with the 9m. They're on the same side, so I can just combine them as is. So we have 15, and we have minus 4m. Now we notice that the 4m's on both sides are negative. They're going to eliminate, so when I add 4m's, they will go away. If you prefer just to cross them out from the start, feel free to do that. These go away. So we're left with 14 equals 15. This is a false statement. So this will tell me that we have no solution again. And that's the general idea of this. So go ahead and work on your IXL and your practice, and good luck.